This is the 5-3 review, number 8. Calculators are allowed. In fact, they're going to be required. In all three of these, we are looking for an antiderivative when we know a point that that antiderivative passes through, and then we want to find the y-coordinate that goes with a second point on the antiderivative. So this is an example of the type of problem that we saw in Skill 3 of Section 5.3, where you are forced to use the fundamental theorem of calculus. The reason you can't do this the way you did in Section 4.10 by just finding an antiderivative and then adding c and plugging in the point is that you will not be able to find an antiderivative of x to the x. So what you'll have to do instead is use the fact that we have a derivative, which is x to the x, and we have a point on the original. So if you recall the notes that I had you write down, that means that the function at any time will be the y value we begin with plus the accumulation from when we had that y value up to x on the derivative function. So if I want f of 7, then that means I'm going to plug a 7 up here. So I'll do 3 plus the integral from 2 to 7 of t to the t dt. Now this is going to take a while to do on your calculator because, again, there isn't a nice, pretty antiderivative, so the calculator really has to crunch for a while. So I will allow you to just type that in, and you should end up with 284,713.901. So 284,713.901 is what f of 7 should end up equaling. If we do the same thing on part B, again we have the derivative and we have a point, and I want another point. So what we'll do is we will first write the equation for the function, which will be the y-coordinate we start with plus the accumulation from when we have it up to x on the derivative curve. Then if I plug in 8 and go to my calculator and type this in just like it's written, then I will, actually not just like it's written, we got to replace that x with an 8, then we should end up with the value 4.330. Then finally, part C, same process. We want f of x will be the y-coordinate we start with plus the accumulation from when we had it up to x on the derivative function. And then to find f of 5, we will simply plug 5 in and then compute this definite integral on our calculator. So just to remind you, those who don't remember how to do this on the calculator, I'll give you the syntax for this one. We would have 2 plus the integral. We open the integral command, then we open the top of the fraction, and then we open what's being squared. So what's being squared is that ln of t. So we close what's being squared, we close the top of the fraction, then we divide. Since the bottom just has one term on it, we can just put a t, then we tell it we want a t because that's the variable we're integrating with respect to, then we give it the lower limit, then we give it the upper limit, and then we close it.